projects that have been created by our students in Research, Design, and Build class, the STEAM Society, and the Robotics team. We also, for the first time this year, are joined by teachers who are here to share all of the projects they do when they aren't teaching in the classroom. Okay, before we get started, we'd also like to acknowledge all the people who made this possible. Mr. Cervantes, Mr. McKee, all of the other STEAM officers up here, the STEAM moderators, Ms. Countryman and Mr. Galling, and our facilities team who cleared up this entire area so you could be here right now. We would truly not be here without any of their dedication. And before we get started, we're going to have Ryan lead us in an opening prayer.
Let us start in the name of the Father, the Son, and the Holy Spirit. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen.
We would like to welcome our keynote speaker, Kevin Walsh. Kevin has a mechanical engineering degree from MIT and a master's degree in manufacturing engineering from Stanford. Kevin is a part of the SJND community as he is the husband of Miss Countryman. He is also a maker, from building model airplanes to bike repair, to building old cars and building an airplane.
Thank you. Thanks for having me. I appreciate it. So 3 weeks ago, my wife asked me, "Could you be the backup speaker at our STEAM event?" And I was like, "Yeah, backup. That's easy." And it was also a little easier because I was in Italy at the time and feeling a little guilty that my family was having to deal without me. So I was like, "Sure, backup. That's fine." And then earlier this week, she's like, "Yeah. So turns out." Speaker, and I was like, "Oh, okay, that's fine." And then she's like, "So it's actually like keynote speaker," and I was like, "This is what we call scope creep when we do projects." Yeah, so here I am, but happy to be here. So how do you make a maker, right? So when I was 8 years old, I was the kid that, like, my mom's food processor, it was my mom because she did all the cooking, not my dad, food processor broke. It's like, okay, well, we can either buy a new one, which maybe we don't have money for, or we can fix it. So I got out what turned out to be my grandpa's tools, took it all apart. It was a belt. And that was like the start of like, oh, you can take these things apart, you can figure out how they work, you can figure out why they don't work, and then put them back together sometimes. So that progressed. My father at the time worked for Schwinn Bicycle, and we had, 30 some odd bicycles and unicycles in our garage. And at 10 years old, I'm now putting bicycles together, taking them apart, changing parts. That led to working on model airplanes, which I was an airplane kid. And that led to like, okay, I can build my own model airplanes, and the model airplanes got bigger and bigger. When I was 12, my father took me to Oshkosh, Wisconsin, which is the largest air show in the world. And as a 12-year-old, I was like, wait a minute, these are just big model airplanes, right? So as a 12-year-old, now I'm taking things apart, putting them back together, making model airplanes, but now it's like, hey, wait a minute, I can build these things and actually get in them. So by 16 years old, I got a job, and the jobs was I worked in a bike shop. I did what's called initial assembly of a bike. So a bike comes in a box, and you take it out and put it together. And that was paying for my flying lessons. I would drive from high school to my job. I'd drive from my job to the airport. I would spend all the money I spent at my job, and then we start over. So I'm now paying for my flying lessons so that I can learn to fly, to build the plane, et cetera, et cetera. So like these things just start snowballing as it goes. And it also got me the first car that I bought, which was also the first car that I bought, which did not drive home. I took it home on a tow truck, and that was not the first one, or not the only one. But that's basically how you make a maker. You start by taking apart something and figuring out how it works, and then figuring out how to put it back together sometimes. So then what? Well, managed to get myself into MIT, which was a huge step for me. I was moving away from home. And very quickly, my freshman year, managed to get myself into a thing called the Versatile Toroidal Facility. So now I'm working on a tokamak as a freshman, which was hilarious to me. And I'm making parts for it. I'm drilling holes in insulators, putting copper bus bars together to make containment magnets, those kinds of things. And this just continues, and I'm able to essentially, as a student, I have a part-time job working at an automation company, and had really, really awesome ability to work on all of these very, very cool projects. This one here is part of the Human Genome Project, where I was able to build a lot of the automation equipment that the Whitehead Institute used to help create the map of the human genome. This middle one here, at the time, there had been an earthquake in Kobe, Japan, and it had leveled all of their industrial manufacturing capabilities. And Alcoa Memory Products, which was at the time the only company in the entire world that made the blanks that make disk drives that were in every computer everywhere. So Alcoa was actually making those under license to Kobe because they decided that having one company in the world do this was not okay. So they essentially helped their competitor. Right? This top one here is probably not obvious. That is the manufacturing process for the Keurig K-Cup. When I was maybe 20, 21, I had the opportunity, Keurig came to the company that I worked with, and they said, hey, we have this idea to make these cups, put coffee in them, seal them up, so you can make coffee. So I worked on that, and that was one of the very most successful projects that I'd ever worked on in my life. That product makes about $4 billion a year for the Keurig company. Yeah. It also made, yeah, clap, clap. It also makes the largest pile of trash like you can imagine. Like we can circle I am not exaggerating, you can circle the earth something like 15 times if you just line up all the K-Cups, right? So when you think about making, think about what happens if you're wildly successful. Think about what happens if you fail miserably, right? Those are both options. And sometimes the difference between those is very small, right? Very, very tiny change in circumstances. So the other thing I did around that time was I managed to finish the car that I had bought, that was taken home on a tow truck, and my now wife and I drove that across the country here for me to start at Stanford. So since then, I've had kind of a lot of opportunities to do amazing different things in totally different industries. These here are aerosol particles for inhalation. I spent a good portion of almost 2 decades working on 2 programs. One was inhaled insulin and one is tobramycin, to make engineered particles so we could control how those particles looked and how big the holes were, so that they go into your lungs and then stay there. and deliver the medicine that they need to. So very, very different from working on a tokamak or making Keurig K-cups or those kind of, disk drives. So a very different industry, if you will, but the same, essentially problem-solving skills and engineering skills required to figure it out. Along that, as you continue to progress, the tools that you will buy will go from the hand drills and the hand tools that you have in your toolbox to the slightly bigger ones. When I was in middle school, I had a drill press and a bandsaw on a countertop in my bedroom, which as a middle schooler does not make you the cool kid. As a 20-something, it's actually pretty cool. But then they get bigger and bigger. That one there is my CNC mill being moved on a forklift. I also managed to finish my airplane. That was about a 10-year effort to go from essentially pieces of an airplane to a plane that we flew back in 2017 now. And I've crossed the country twice in it. My family and I have taken some really cool vacations in it as well. But essentially, it's just a big model airplane, right? The pieces are bigger, the ideas are the same. I've had some really great opportunities, like I said. This middle one, I always think it's funny to show like giant trucks inside of buildings. This is when I worked at Tesla and we built essentially a tower of batteries that went from the second floor to the first floor. So this is a dump truck dumping, essentially filling the cement base that was going to be at the bottom. Worked for an electric motorcycle company as well. And then, I don't know how many of you know this, but on this island, there's a company that makes rockets. And for the last 5.5 years or so, I worked for Astra, doing exactly that. And I joined there to essentially do manufacturing engineering. And as I worked there and gained more responsibility, when I left there just about a month and a half ago now, I was the director of launch product development, which meant I was responsible for essentially development of our new launch system. So essentially, same thing, what's the engineering, what are the requirements, can we build something and test it to those? But at the same time, COVID hits, we don't have people in the factory. Kevin crawls through inside and is sitting inside of the rockets, putting them together so we can get them to the launch pad, right? So that was a really, really cool, very first time that I was actually able to do aerospace engineering in my entire career, despite being an airplane kid. Always has been something else. And this is what I do now. So about a month and a half ago, I started. For those that don't know, this is from a company called Zoox, which is an Amazon company, and we make an automated, essentially autonomous vehicle. It seats 4 people. There is no steering wheel. There are no pedals. It drives by itself. And we are intending to scale these such that instead of calling yourself an Uber or an Lyft, you can essentially call a Zoox. And why does this matter? About 95% of the time, even people that drive for Lyft or Uber and are driving much more often, about 95% of the time, personally owned vehicles are sitting and doing nothing. Right? They sit in a parking lot. They're parked in your driveway. They're parked on the street. They're taking up a lot of resources to build those things to sit and do nothing. Right? So if you could move to a model where you don't actually have to own a vehicle, you don't have to call an actual person to come and get you, the robot can essentially drive to you, open up, there's 4 seats inside, and take you off to where you're going. This works. I've ridden in them. They're down. We drive them in two sites right now, and soon you'll see them more prevalent. But really making a difference in terms of both it's an electric vehicle and also an autonomous vehicle where the usage rate is significantly higher than a personally owned vehicle. So that's what I'm doing now. My new role is called Factory Launch Manager, so I'm building the factories that help build the robots. So in Terminator, I guess I'm the bad guy that starts the list of the robots that make the robots. And now I'm making makers. Those two sitting back there. This is the same car. And this is Amelia and I have it up on blocks. We're weighing it to get the center of gravity, both fore aft as well as vertical, which you can do by setting it horizontal and then lifting it one direction, lifting it the other direction, and taking all the weights. You can measure essentially vertical CG. And we're doing that because this is the before from gutting out the ice to put in an electric conversion. So that's that one. And then that's Otto with one of his water gun projects. But helping those two, essentially being the guy that wants to hand them an appliance that's broken and say, like, what's wrong with this, fix it. Cut the cord off so you don't hurt yourself and like go to town, right? So that's my life as a maker. It's taken me a lot of different places, doing a lot of different things, and it's been super fun. So I'm excited to see all the projects that you guys have here and like see like this is what I was doing when I was your age, and yeah, excited to see where you guys will go. Thank you.
Any questions before he leaves? Any questions?
Can you speak a little bit about like why your company chose to make the car as electric versus like something else, like hydrogen based or gas?
Yeah. So in trying to make a car or a vehicle that's essentially sustainably powered, as opposed to like an ICE car, internal combustion engine ICE, you've got some very obvious choices, which electric is one. You've got some less obvious choices, which hydrogen is one. Hydrogen turns out to not be an energy source, if you will. Hydrogen turns out to be a storage solution. As storage solutions go, hydrogen has some challenges, not the least of which you need what's called a COPV, a composite overwrap pressure vessel, where you store hydrogen at usually about 6,000 or 7,000 psi, which is not great from like a crash perspective, although they do lots of things to make sure that it is. The other problem is that you need actually an ability to like recharge a vehicle, and the available infrastructure for hydrogen is actually incredibly poor. The available charging infrastructure for EVs, although here in the Bay Area we think it's great, it's actually super poor, and that, like building out that infrastructure is part of what we also have to do. The vehicle that we have here has a battery in it that's like 50% bigger than like a Model SX Tesla, so they're very large batteries, and it's because our use case for this is that it should be on the road driving customers like 18 hours a day, right? So you need essentially very large storage capacity and the ability to then, like, all of your downtime is basically charging.
So like, would you have to pay for each ride, or is it like a subscription?
So it's not available yet. I have the app on my phone. No, like you can't yet, right? So unfortunately, the idea is that you will treat it exactly like an Uber. You will, or a Lyft or any of the other rideshare services, right? You say, I am here and I want to go here. A Zoox will pull up, the doors open, you sit down, it takes you there, and that's it. Yeah.
Is it cheaper if you're an Amazon Prime member?
Zoox is an Amazon company, and I have no idea how that's going to work, but almost certainly that's how it will work.
What is like the charging procedure? Do they all like go to some warehouse together?
Yeah. So how do you do operations for an autonomous vehicle set? Yeah. Right now there are depots that we are building. There's actually a depot in San Francisco right now. There's a depot in Foster City. We have a depot in Las Vegas. And yes, the autonomous vehicles essentially pull in, and then a person plugs them in. Yeah.
I'm also curious about like theft prevention.
Abuse scenarios are something we think a lot about. Yeah. First thing first, there are so many cameras on this thing, you're not getting away with a whole lot.
Is there, I know like solar battery, solar charging, I don't know if it's practical in the context of
Yeah, so total, like, if you calculate solar density versus like square meters, 140 kilowatt hour pack versus the solar panels. This is a very small car, right? The overall length is smaller than a Mini, right? It's like 12 something feet long. It's essentially all interior space, basically, right? So the total space available on the top is very, very small for that. It's also a skylight up above, so it's very nice to have that. Yeah.
Different question from the Zooks. Going back to, so you went to MIT.
I did.
And you're in a field, I think a lot of people might think of it being very competitive. But everything is manufactured. Like if you look around this room, there isn't one thing that wasn't designed by somebody. Right? And not only, like you say, the thing, but the thing that makes the thing, right?
Yes.
So we have a room of young engineers. Do you have any advice for like what they can do or like?
Sure. As a like middle school, high school kid, if you told me like manufacturing engineering was a thing, I'd be like, I don't know what you're talking about. So I wouldn't say that like that was the thing I said like, oh, like that's what I'm going to do, right? So like if you haven't got it all figured out by today, I know you all probably think you got it all figured out, but like if you don't, it's fine. Like you can adapt and change. The thing for me that really drew me to manufacturing was that the difference between a really good product that really got into a bunch of people's hands and a really good product that no one had ever heard of is almost always manufacturing. It's almost always, did somebody think enough about how they were actually going to make the product to get it to you that makes the difference. There's a really cool curve of product development, and by the time you develop a product, right, you've spent like, okay, I've got an idea and I've done all the engineering to say like this is the product definition. You've done approximately 10% of the work to actually make that product to get to market. But by the time you've done that 10% of the work, you've committed 90% of the value of that product when it reaches a consumer's hands. Which means that you've already made all of the decisions that are going to make the difference between this being a product that is going to cost way too much and no one will ever afford it or they'll think it's not worth it, or you've been very, very thoughtful about how you're going to make it and clever about how to package it or something like that to make it so that you can actually make it at a price that someone's going to pay for, right? So that curve, that 90-10 is amazing to me, that like I can be so short into the life cycle of a product, but yet I've essentially finished with how much it's going to cost when I'm done, right? So you got to be super, super thoughtful at that first 10%. Yeah.
What like inspired you to switch from Astra to Zeus?
That's a good question. Rockets are an incredibly difficult problem. Margins on rockets from a design point of view are very, very small. We typically engineer things in rockets. We typically engineer things to 1.1 yield, right? So like if I'm gonna design, say, the skin of the rocket, and I'm gonna pressurize it or I'm gonna bend it when it's in flight, I develop those load cases to 1.1 times, so 110% of what the material can do, right? So everything is very, very tight. So the margins on everything you do and the amount of engineering effort that it takes to get there is very, very high. But once you have a launch vehicle, you're basically, again, you've made all of the decisions and choices about what that can do. And the launch landscape in the 5 years that I was there changed radically, right? Two things happened. One, SpaceX decided that they could continue to make even more money flying the Falcon 9 by flying what they call rideshare. Small satellite providers could essentially launch with SpaceX where they would like stack up 40 or 50 different satellites and send them all out. So that brought the cost per kilogram to orbit very far down. The other thing that happened was Russia invaded Ukraine, which stopped everyone from flying Soyuz flights. So the total metric tons from Earth to orbit, low Earth orbit, went down for the first time in forever, because a launch provider was essentially, no one would ever fly with Russia. And you now have SpaceX continuing to essentially push the bounds of what they're willing to fly. So the value proposition of a small launch vehicle like we have, which is the small launch vehicle there, which is called Rocket 3, we could realistically launch about 100 kilograms, which for most satellites, like for what are called like 3U or 6U satellites, that's fine. But the thing about satellites is they continue to grow, right? So the size of satellite that you need for, say, Starlink or Project Kuiper, which is an Amazon project, went to more like 500 kilograms, right? So in response to that, we built Rocket 4, which is the one behind it, which was targeted at like about 500 or 600 kilograms. But the timelines to do that are never short, right? And it essentially just became a game of like, did we have the financial resources to be able to continue to do that? Yeah. So for the first time in about 5.5 years, I essentially made a choice to change from one to the other. Yep.
You've switched to like a lot of really cool jobs. How do you set yourself up to be somebody who can have a massive amount of latitude in their skill and where they're able to go and what they're able to do? Like, how did you set yourself up as somebody who can go from aerosols to space?
Yeah, that's a question I get a lot, right? To me, they're no different. It is no different to me to make a small aerosol particle that goes in your lungs than it is to make a rocket that goes to orbit, that is to make an automated vehicle that comes and picks you up and drops you off, right? To me, they're all engineering problems that need someone to define a set of requirements, someone to propose a solution and test it, and then someone to do all the hard engineering work in order to essentially make a product, right? So to me, they're all engineering problems, and I've always posed them that way, right? I've very intentionally made my career not be one industry and doing that, right? For a long time, it seemed that way. I worked in aerosols for almost 20 years. And that's because the product life cycle in aerosols or in pharmaceuticals is very, very long. That was 2 programs, right? So I would put it to you this way: like, engineering is a way of looking at the world. It's not a singular job in a singular industry. Yeah.
You built that plane up over there. Where do you even start to build a plane? Did you have to design it, or did you?
No.
Did you just buy parts, or do you make your own parts from a roll of sheet metal, or what do you do?
Those are all great questions. It's a composite airplane, so it's basically made out of foam and fiberglass. The foam you cut with a hot wire. I don't know if any of you have hot wire cut foam. That's how you cut the foam, and then you make sure it's all nice and true, and then it's essentially foam or fiberglass and epoxy over the top. There's a set of plans that you buy that's about $500. It's a set of 11 by 17s, and it's like maybe 500 pages, and it's literally step by step on how you do this. But yeah, that's how you do it, and then it takes a significant portion of your life. That's how. Yeah.
How many hours did it take, and what engine is it?
It took about 10 years. I'd never added up how many hours I actually spent working on it. I've also never added up how much money it costs, so I'm not going to do either of those 2 things. It's a standard airplane engine. It's a Lycoming 0360 horizontally opposed 4-cylinder engine. I did a little bit to it, so it's a couple hundred horsepower. That plane right now will do about 155 knots, so what's that, 175 miles an hour. Once I actually put the rest of the wheel pants on, it'll be closer to 200 miles an hour, but yeah. And it seats 4 people, so our whole family can fit. We haven't tried the dog yet, we'll see. Yeah, more than I can hold my bladder. I've flown it from San Carlos Airport to White Rock, Wyoming, which was about like 1,100 nautical miles or something like that in one go. Yeah.
So what is the headspace like?
Yeah, you go like that. I had my dad inside the plane. He's 6'4". We had to take all the seat cushions out because the seat cushions push you up and a little too close to the canopy. It is very tight. Yes.
What's going through your mind when you're first taking off in the airplane? Because you've got to make sure that everything goes right.
You totally do. So there's, I actually made the checklist for these vehicles of how to do a first flight in them and all of the things that you do getting up to that. And one of the things you do is evaluate your own fitness to be able to be that guy. I have the distinct advantage of having a friend who is an instructor at the National Test Pilot School and on the F-35 program testing the F-35s, who flies the exact same plane. So I made the very logical choice to not fly my first flight, and I had Raven do it. So, yeah. Anybody else? Cool. Thank you.